Molarity. This word always strikes me as funny because if you switch two of the letters, you get morality. Isn't that funny? Okay, never mind. Molarity. Sometimes chemists use percent concentrations, but more frequently we use molar concentrations or molarity. Those mean the same thing, to express solution concentrations. And we do this because molarity, instead of using mass of solute, uses moles of solute. And oftentimes chemists are interested in these counting numbers. We want to know how many atoms or molecules we've got. So molarity is abbreviated with a capital M. And I've seen this in my Chem 1A and Chem 1B students. They use capital M as an abbreviation for mole. That's not an abbreviation for mole. Capital M is moles per liter. The abbreviation for moles is mole. I know it's not much of an abbreviation, but there it is. Capital M by itself means moles per liter. It's easy to forget. We like to use it when we type stuff because it's easy. You don't have to use the slash or format things funny. You just put in a capital M. And you see that in the lab on bottles. It'll say 3M solution. That does not mean it's made by Minnesota Mining and Manufacturing. It's the concentration of the solution. So the molarity, capital M, is the moles of solute divided by the liters of solution. So in a percentage, we could use any mass unit that we wanted because they ended up canceling out. But here, for volume of solution, it has to be liters, and the quantity of solute has to be moles. Molarity works as a unit factor as well because it relates moles of solute to liters of solution. So let's look at a 2.5 molar sodium hydroxide solution. 2.50 capital M. So we read that molar, like your tooth molar. So 2.50. When you see the capital M and you write it down with your hand and your pencil, write it like this: moles over liters. That tells your brain this is a fraction. This is a ratio. This could be a unit factor. So that is moles of sodium hydroxide per liter of solution. So that's one unit factor. Another unit factor is tip that over, right? 1 liter of solution per 2.50 moles of sodium hydroxide. How would that relate to milliliters of solution? How many milliliters are in a liter? Milli means 10 to the minus 3, right? So 1 milliliter equals 10 to the minus 3 liters. Well, what if we want to know what 1 liter is? 1 liter is how many milliliters? 10 to the positive 3. What? How did I do that? Let me show you. So let's divide this side by 10 to the minus 3, and let's divide that side by 10 to the minus 3. Those cancel out. 10 to the minus 3 is the same as 1 over 10 to the 3, right? So here I have 1 over 10 to the minus, 1 over 10 to the third, which is 10 to the third. So this guy right here, this equals 10 to the third. And you can do that on your calculator and prove it to yourself if you want to. So 1 liter is 1,000 milliliters. And now I've just made a big mess. Yeah, whatever. Oh, it's fine. 1,000 milliliters, or 10 to the third milliliters, is equal to 1 liter. So then for this guy right here, instead of liters down here, I could write 1,000 milliliters, 2.50 moles of sodium hydroxide. Yeah, I got the right compound that time. Per 1,000 milliliters of solution. Any questions? I could also tip that one upside down. 1,000 milliliters of solution per 2.5 moles of sodium hydroxide. So solving molarity problems. Calculating the molarity, we're going to use the equation. The molarity is equal to the moles of solute divided by the liters of the solution. So we have to figure out our solute in moles and our volume of solution in liters, and then we take the one and divide by the other. Another type of problem is they ask for mass of solute or volume of solution, and they give you the molarity. Then you use the molarity as a unit factor. Sometimes you might need the molar mass of the solute, because sometimes they give you like grams of solute, so you have to convert it to moles. And you're often going to need to convert milliliters and liters, because milliliter is a much more useful size volume unit in the chemistry lab than a liter is. So we use milliliters a lot. So let's do a couple examples. Calculate the molarity of a solution containing 1.50 grams of KCl in 250 milliliters of solution. So they want molarity. So we remind ourselves what molarity is. Molarity equals grams, moles of solute divided by liters of solution. Do we have either of those quantities exactly? No, that'd be too easy, wouldn't it? We've got 150 grams of KCl. That's the solute, but we need moles. But we could fix that, right? 1.50 grams of KCl, and we want to convert that to moles of KCl. So we need to divide by grams of KCl. The relationship between grams and moles is the molar mass, right? So we look at the periodic table. I'll do that up here. And potassium is 39.10. There's 1 K in the formula. And chloride is 35.45. There's one of those in the formula. We add those together. 39.1 plus 35.45, 74.55. Grams of KCl is equal to 1 mole of KCl. That's what a molar mass tells us. So that's the factor down here. 1 mole weighs 74.55 grams. So I've got 1.50 divided by 74.55. 0.02012. I did write the 2. I didn't just say it. That should have 3 significant figures, right? Because this one has 3. I'm just going to carry that extra one along because I don't want to have any rounding errors. That's a small number. Sometimes students are like, oh, wait, that's a small number. That can't be right. No, it's going to be a small number. 1 mole of this stuff weighs 74 grams. We only have 1.5 grams. It's a small number of moles. So that's our number of moles, 0.02012 moles of KCl. And then they gave us milliliters of solution. Once you become familiar with milliliter liters, you can just move the decimal point over 3 places. It's 0.2500 liters. But I'm going to assume that a lot of you are not okay with that, so we'll write it out. 250 milliliters. And then we want it in liters, so we have to divide by milliliters. And then we ask ourselves, what does milli mean? 10 to the -3. So I've got milli on the bottom. I write what it means on the top, 10 to the -3. I do the math, and I come out with 0.2500 liters, capital L. So 0.2500 liters of solution. So I take my 0.02012 divided by 0.25. I guess that's right. And this should have 3 significant figures, 0.0805, capital M. Capital M, when you're writing it by hand, sometimes looks like a lowercase m. So this guy right there, is that a lowercase m or a capital M? Lowercase? No, it's uppercase. Whichever someone says, I'll do the opposite. Because I can. You can have some fun in life. The relative size is what determines whether it's molarity or meters, because lowercase m is abbreviation for meter. And so what a lot of chemists do is they'll underline the capital M. It's molarity, not meters, because it'd be bad to get that confused. So any questions about this guy? Calculating molarity. Got to find the moles of solute. That may require some steps. You have to find the volume of the solution in liters. With the percent concentration, I promise you I will try to trick you on the exam. Most of the time I've said, oh, I won't try to trick you. No, I will try to trick you on that one. I'll give you a problem where I give you the mass of the solute and the mass of the solvent and ask you to find the percent by mass. And several of you, at least, will forget to add them together. And that wrong choice will be one of the choices. Okay? So I'm telling you that I'm going to trick you. Okay? On molarity problems, we do not try to trick you because it makes the problem really, really difficult, actually. So for molarity problems, it's always going to be volume of solution. The mass percent problems, no, that's going to be tricky. Okay, another one. What volume of 6 molar hydrochloric acid contains 10 grams of HCl solute? So hydrochloric acid and HCl, same thing. And here, they've been nice. They gave us the molar mass of HCl. Not that it would be so hard to calculate, but we'll take it. We'll take it. So this capital M means moles per liter. So that's 6.00 moles per liter. And then we've got this number, 36.46 grams per mole. And then we've got a quantity, 10.0 grams of HCl. With this problem, we can actually just stick these numbers together so that the units cancel out. We don't even have to really understand what's going on. But it's nice to understand. So we have a solution that has 6 moles of HCl for every liter of solution. This is the molar mass, and this is the volume, the mass of solute that we want to find. So this is the number that we're going to start with. We're going to start with 10 grams of HCl, and we want to find what? The volume of solution. Probably liters. That would be easiest. If they don't give you a unit, pick an easy unit. Don't make things harder. So we want to get to volume. Well, this is a conversion factor that involves volume, but it involves moles, and we've got grams. So we need to use this one first. So we're going to go from grams to moles and then to liters. We have grams of HCl down here. Those units are going to cancel out. And then we're going to have moles of HCl down here. And those will cancel out. Get all the units in first. They tell you what to do. You don't have to remember, should I multiply or should I divide? Let the units tell you. So here, grams per mole. We look at this conversion factor that was given, 36.46 grams per 1 mole. So 1 mole on top, 36.46 grams on the bottom. And then this is the relationship between moles and liters. It's 6 moles to 1 liter. So over here, 6 moles on the bottom and 1 liter on the top. 10 grams divided by 36.46 divided by 6 equals 0.0457, and the unit is liters. This number has 3 sig figs, this one has 3, and that one has 4. The smallest number of significant figures is 3, so that's why I rounded my answer to 3 significant figures. Any questions? This question is missing something. Let me fix it. What is the mass of solute in 25 milliliters of 0.912 molar CuCl2? We're asked for mass of solute. Well, let's write down the things that we have. We have 25.0 milliliters of solution. And we have 0.912. Capital M means what? Moles per liter. So that's moles of solute, which is CuCl2, per liter of solution. And we want grams of CuCl2. That's what we want to find. We're going to do this with unit analysis. We should start with this one, because that can't be used as a unit factor. This will be a unit factor. So 25.0 milliliters of solution. I need to use this, but this has liters in it. I can tell that I'm going to run out of space. I'm going to get rid of that word. Can I convert milliliters to liters? Sure. So if I convert milliliters to liters, then I could use the molarity in here, right? It's like putting together a jigsaw puzzle or something. And could I get from moles to grams? Yep. Yes, I could. So moles per liter is that unit factor given in the problem, the concentration. 0.912 moles per 1 liter of solution. This guy is our old friend, milli. Milli means 10 to the minus 3. And where are we going to get this one? Grams per mole. Molar mass, periodic table. 63.55 for copper, plus 2 times 35.45 for the chlorine, 134.45 grams per 1 mole. So 25 times 1 times 10 to the minus third times 0.912 times 134.45. And this should have 3 significant figures, 3.07 grams. Any questions? Molarity calculations are really, really important in chemistry.